What's going on, everybody? In this video, we're going to start talking about binomial expansions. And binomial expansions are a way of us taking any kind of polynomial and expanding it to whatever degree that the question is asking us for. This video is going to focus on utilizing Pascal's triangle in order to do that. So what I've given you right here, these are the two formulas that we're going to look at. And they're very simple. They look a lot more in depth than what's going to happen. But what we need to know is that we have an A term, a B term, and it's raised to some specific power. Now, this power, this n, refers to a specific row in Pascal's triangle. And that is what we're going to look at during this video. Then we're going to follow this very specific pattern for each one of them, but it doesn't matter which formula we use because Pascal's triangle is symmetrical. So it doesn't matter whether our A term is adding or if it's subtracting, we will wind up with the same answer. And I typically always use this one here just out of habit, but anyway, I will show you exactly what all that means in just a moment. Now, the first thing that we need to be familiar with is Pascal's triangle. The way that we're going to look at Pascal's triangle is that Pascal's triangle is going to start on row 0, and that is 1. Now, row 0 and row 1 are very kind of a given beginning principle because we have 1 and 1 on that side. Now, once we have those first two rows, we can apply this very, very easy method of solving Pascal's triangle to get row 2, 3, 4, 5, and all the way down. So the way that we do it is every outside column is going to be 1. And then we take whatever these two numbers are and we add them to give us the middle number. And then again, those outside columns are 1. So 1 plus 1 gave us that 2. So now we have 1, and we have 1 plus 2 gives me a 3. A 2 plus 1 gives me a 3, and my outside column is a 1. Then I have a 1 on my outside column. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. And obviously a 1 there, and that gives me row 4. Row 5, continuing on down, we have 1, 5, 10, 10, 5, and 1. And that's how we solve through Pascal's triangle. That gives us any row that we could venture to look for. Very easy, very simple. So we can use this in order to solve problems like this. Perhaps they wanted us to expand 3a plus 2 raised to the 4th. Now, we could FOIL this out and then start distributing and do all that. That's fine. However, I don't want to do that if I have an exponent that may be to the 13th power. So I know that this is telling me I need the 4th row of Pascal's triangle. So we have 1, 1, 1. That's row 0 and 1. Row 2, row 3, row 4. Well, that's easy. And so now I can use my formula of a plus b to the n equals, where we have to the n choose k of a to the k and b to the n minus k. And so what this means is when we expand 3a plus 2 to the 4th, well, that equals, we take our n value, which is 4, and we start at 0. And then we put our a value, which here is 3a. And actually, I'm sorry, I'm going to do it with this one here. I always like to start with my first coefficient having that higher power. And then my b value is going to be 2 to the 0 plus, and then our combination just adds 3a to the third. That first term, that a term, is now decreasing by a power of 1, 2 to the first, plus and we continue on this method. Okay, and now we can start simplifying. Well, this number, 4 choose 0, is the first term in row 4 of Pascal's triangle. So I have 1 times 3a to the 4th is 3 to the 4th, a to the 4th. 2 to the 0 is 1, so we can just leave that off. 4 to the first power is 4 times 3 cubed, a cubed, times 2, plus 4 choose 2 is that third term in row 4. So we have 6 times 3 squared, a squared, times 2 squared is 4. 4 choose 3 is 4 times 3a times 2 cubed is 8, plus 4 choose 4 is 1. 3a times 0 is 0, or sorry, 1. 3a to the 0 power is 1. 2 to the 4th is 16. And now we can simplify this out. The 1, I don't need to keep it. I have 81a to the 4th plus 4 times 2 is 8. I'm multiplying these two first. So 8 times 27, we know, is 216 times a cubed plus 6 times 4 is 24 times 9, because that's 3 squared, gives me 216 a squared, plus 4 times 8 gives us 32, times 3 gives us 96a plus 16. And so now, once I have all of this, I'm done. I have all of my different expansions here with my coefficients and my constant. Now, what if the question said find the fourth term in the expansion? Well, I'm going to do everything the exact same way that I did, and then I'm going to count 1, 2, 3, fourth term. Fourth term would be 96a. And that's it. So I hope this video helps you understand how to complete these binomial expansion problems utilizing Pascal's triangle. I hope that you feel a lot more comfortable with creating Pascal's triangle and solving these expansions through that. So thank you for checking out the video. We'll see you guys next time.